Welcome you all. So in today's section we will see block diagram reduction technique. That is how we will find the transfer function from the given block diagram using block diagram reduction technique. So this is our block diagram. So block diagram is the pictorial representation of all the functions performed by each component. So we know this is the block diagram. So block diagram will have mainly three components. So this is the block, and this is a summing point, and this one is the branch point. So this is one example for block diagram. So from this block diagram we have to find the transfer function. So for finding the transfer function using block diagram reduction, we have some rules. We have some 11 rules for the block diagram reduction. So we will see one by one. So this one, rule number 1, this one is our rule number 1, combining the blocks in cascade. So if the blocks are given in cascade or series, how we will reduce that block to one block. So if suppose we have G1 and G2 blocks in series, now we will combine these blocks to one block by, if the blocks are in series, then we have to multiply that two blocks to get to make it as one block. Okay, so here G1 and G2 are two blocks. Now multiply G1 and G2 to get one block. That is rule number 1. Now rule number 2 is combining the blocks in parallel. So if the blocks are in parallel, so here G1 and G2, G1 block and G2 are in parallel. So here we can see these two blocks are in parallel. So when we use the block diagram reduction rules, one important thing is there should not be any change in the input and output. So here we are giving signal A as the input. Okay, so A is the input and the output is A into G1 plus G2. So there should not be, when we reduce the blocks, there should not be any change in the input and output. So here we can see when we reduce these two blocks in parallel to one block, here we can see, so signal A is the input and output is A into G1 plus G2. So for getting one block from these two blocks, we have to add G1 and G2. So if the blocks are in parallel, combining the blocks in parallel, we have to use the rule to add the blocks. We have to add the blocks in parallel. So here G1 and G2 are the blocks in parallel, then add that two blocks, G1 plus G2. Now rule number 3 is moving the branch point ahead of the block. So here the branch point is here. From this branch signal A is coming. Okay. So when we move the branch to after the block, this branch after the block, there should not be any change in the signal which comes in that branch. So when we move this branch point after the block, when we move the branch point after the block, we have to add an inverse of the block. So here we are moving branch point after the block G. So add one block of that G, inverse of that block, that is 1 divided by G in that branch. So here in this branch we have to add one block, 1 divided by G, then the output will be A. So here in this branch the output is the signal which goes is A. Then here also after moving the branch we are getting signal A. Okay, now rule number 4 is moving the branch point before the block. So here we have to move this branch before the block. So here in this branch the signal is AG. So there should not be any change in this signal AG. So for getting that we have to add one block, that is G. Then the output will be AG. Now rule number 5 is moving the summing point ahead of the block. This is the summing point and we have to move this summing point after this block G. So for moving that summing point after the block G, we have to add one block G in that branch. So here in this branch, that is in the branch which has the signal B, we have to add one block G. So we will get the output G into A plus G. That is the output here, A plus B into G. That is the rule number 5. Now rule number 6 is moving the summing point before the block. So we have to move this summing point before the block G. So for moving the summing point before the block, we have to add an inverse of that block. That is, we are moving the summing point before the block G. So we have to add inverse of that G, 1 by G in that branch. Okay, here we will add one inverse of this branch, inverse of this block G. That is 1 divided by G. So this is the rule number 6. Now rule number 7 is interchanging the summing point. So we have two summing points and we have to interchange that summing points. These two summing points, we have to interchange that summing point. So these rules are, we are doing these rules to reduce the block diagram. So when we used to reduce the block diagram, we have to apply some rules. So if we are applying the rule interchanging the summing point, we have to do like this. Okay. Now rule number 8, that is splitting the summing point. So here the summing point, we have 3 signals. So we know the summing point is the summing point is used to add 2 or more signals. So that is summing point. Here we are adding 3 signals, A, B and C. So the output is A plus B minus C. So we have to check the sign. So here for signal C, here the sign is minus. So we will get the output A plus B minus C. So by adding these 3 signals, we will get the output A plus B minus C. So by splitting the summing point also, we have to get the same output, A plus B minus C. So this is the way we split the summing point. Now rule number 9 is combining the summing point. Here we splitted the summing point. Now rule number 9 is combining the summing point. Here we have 2 summing points. Now combine that 2 summing points to get 1 summing point. That is A plus B minus C is the output. Now rule number 10, elimination of negative feedback loop. So negative feedback loop means, so here we have the sign minus. So when this feedback loop have the sign minus, then we say it as negative feedback loop. So if the loop is like this, if it is given like this negative feedback loop, for eliminating this one, we have one formula, G divided by 1 plus G into H. So G is the block here, H is the block here. So we have to use the formula G divided by 1 plus G into H. Now rule number 11 is elimination of positive feedback loop. Here we have the sign plus. So this is the positive feedback loop. So eliminating this one, we have to use the formula G divided by 1 minus G into H. So these are the 11 rules. By using these 11 rules, we have to reduce the block diagram. So we can see one question, reduce the block diagram shown in figure and find C by R. C by R is the transfer function. So reduce the block diagram to find the transfer function. Now this is the block diagram. By using the rules, by applying the rules, we have to reduce this block diagram to transfer function. So for that, first see, is there any blocks in cascade or series? So here there is no block in series or cascade. These two blocks G1 and G2 are nearby, but here in between we can see one branch point. So these two blocks are not in series. So we have to make the blocks in series, or some other way we have to reduce the block diagram. For that we use step 1, move the branch point after the block. We have to move this branch point after the block G1. So here we are moving this branch point after the block. So when we move this branch point after the block, use the rule. So when we move this branch point after the block, add one inverse of that block. So here we are moving the branch point after the block G1. So here in this branch, add one block inverse of that G1. So here we are adding 1 divided by G1 in that branch. Okay. So then this block diagram will come like this. Here we can see one negative feedback loop. Here we can see one. Here we can see 2 blocks in cascade. Now eliminate this negative feedback loop and also combine the two blocks in cascade. Then for combining these two blocks in cascade, what we have to do, we have to multiply these two blocks. And for eliminating the negative feedback loop, use the formula G divided by 1 plus G into H. So here we have done that. That is, for eliminating this one, we have used the formula G divided by 1 plus G into H. That is G1. Then we will get the block G1 divided by 1 plus G1 into H1. That is here, G1 divided by 1 plus G1 into H. And for combining these two blocks, how we will combine? Multiply these two blocks. That is G3 divided by G1. So here we got G3 divided by G1. Now, when we see this one, we can see there is two blocks in parallel. Okay, these two blocks are in parallel. So combining the blocks in parallel, we have to add the blocks. So you have to add G3 divided by G1 and G2. So G2 plus G3 divided by G1. Now we got two blocks in series or cascade. So what you have to do for combining these two blocks? You have to multiply these two blocks, G1 divided by G1 plus G1 into H, and multiply with the G2 plus G3 divided by G1. So here we multiplied these two blocks, the values G1 divided by 1 plus G1 H1 into G2 plus G3 divided by G1. Then we got the transfer function, overall transfer function as C divided by R is equal to G1 by taking here take the LCM and cancelling G1 and G2, G1. Here we can cancel this 2 G1. Then we will get G1 G2 plus G3 divided by 1 plus G1 H as the answer C by R. That is a transfer function. Thank you.